Hello guys, our today's topic is history of the atom, atomic theory. How we perceive atoms has changed vastly over time. Thanks to the work of scientists all over the globe, here we will look at the main 5 atomic models over the last 200 plus years. By the end of this lesson, you will be able to describe the key contributions of Dalton, J.J. Thomson, Rutherford, and Bohr to atomic theory. You'll be able to explain how the atomic models evolved over the time based on scientific experiments. You will be able to compare and contrast different atomic models like Plum pudding model, nuclear model, Bohr model, etc. So fair. Atoms were first proposed as the smallest unit of matter by Democritus, a Greek philosopher. Atom comes from Greek word atomos, meaning indivisible. That is, it cannot be cut further. After this, John Dalton extended his theory, saying that atoms are tiny, hard spheres that are indivisible. That is, it cannot be cut further. Atoms of same element are identical. Example, oxygen is made up of all oxygen atoms. For instance, oxygen gas is written like this. So oxygen gas is made up of all the oxygen atoms. Then he told combination of different atoms make compounds. There's a question time. Which statement is not part of Dalton's atomic theory? All atoms of an atom element are identical. Atoms can be created or destroyed. Atoms combine in a simple whole number ratios. Atoms of different elements are different. Pause, think, and answer. If you answered B, you are absolutely correct because Dalton believed that they were indivisible. It cannot be destroyed further. Next comes the Plum pudding model by J.J. Thomson. Thomson carried out experiments and discovered that atoms were not solid sphere. Dalton told that atoms are solid sphere, whereas J.J. Thomson told that they were not solid sphere. Atoms were made of smaller particles which are negatively charged called electrons. So electrons came into existence in J.J. Thomson's model. After the discovery of electrons, he suggested that atoms have electrons which are embedded in a ball of positive charge like plums in a pudding. This whole atom is positively charged, and he told that electrons, which are the negatively charged particles, they are present in this positive charge like plums are present in the pudding. There's a question time. What was the name of J.J. Thomson's atomic model? Plum pudding model, nuclear model, quantum model, and planetary model. Pause, think, and answer. If you answered plum pudding model, you're correct. Next come is the nuclear model by Ernest Rutherford. He did gold foil experiment. What he did was he fired positive alpha particles at gold foil. Some rays deflected, but most passed through. He gave some observations after the experiment. Observation from the experiment: most of the alpha particles went straight, some were deflected at an angle, very few rebounded back. What he did was he passed positive alpha particle rays from a thin gold foil. There was a detector around it to detect. The detector was made of zinc sulfide screen. It was fluorescent material, so whenever there were spots, they could be easily traceable. What he observed that very few rebounded back, that is deflected at 180 degree only, not Celsius, sorry. Then few went straight away and very few deflected at a certain angle. Most of the alpha particle went straight through. You can see this, you can see this, you can see this and this. They went straight. Some were deflected at an angle. You can see this and you can see this. They were deflected at certain angles. Very few rebounded back, that is, came back from where it originated. From his experiment, he concluded three observations. The alpha particles which went straight through, from this he concluded that most of the atom is empty space. This 1, 2, 3 and 4. Okay, this was empty space. Very few alpha particles rebounded, that is this one, number 5th. From this he concluded that a nucleus is present in the center of the atom. Some alpha particles were deflected at an angle. Nucleus, you can say this 6th and 7th, they were deflected at certain angle. Nucleus must be positively charged, that is why it is repelling it, with negative charge orbiting around. There was some negative charge as well. There's a question time for you. What was Rutherford's key discovery? Atoms are indivisible. Atoms have a dense positively charged nucleus. Electrons are embedded in a positive sphere, or atoms have no empty space. Pause, think, and answer. If you answered B, atoms have a dense positively charged nucleus, then you are absolutely correct. Rutherford's later work, he told that nucleus has some mass and some positive charge. In this nucleus, there is some mass and some positive charge. The term protons was given to this positive charge. Next comes the planetary model by Niels Bohr. Failure of Rutherford's model led to the discovery of Niels Bohr planetary model. The model could not explain why the atom did not collapse if there were electrons orbiting around the positive nucleus. Now just think that Rutherford told that there are electrons orbiting around the positive nucleus. The question arise was why the electrons, the negatively charged particles, get attracted to the positive nucleus and the atom collapse. So this led to the formation or discovery of planetary model. Niels Bohr in 1913 gave statement that electrons move around the nucleus in orbits at a fixed distance. These electrons are at a fixed distance from the nucleus. This is the nucleus, and the electrons are at a fixed distance which are revolving in their orbits. Electrons fit into specific energy levels or orbits. These are the energy level or which we call orbits. Why the name planetary has been given? It is because the scientists compared this model to planets revolving around the sun. If this is our sun, the planets are revolving around the sun in a fixed orbit. Similarly, the electrons are revolving around the nucleus in fixed orbits. Question time again. What did Neil Bohr's model explain that Rutherford's did not? Existence of protons, structure of the nucleus, electron energy levels or shells, or the neutrons? Pause, think, and answer. If you answered C, electron energy levels or shells or orbits, you are absolutely correct. Other noticeable discoveries: in 1932, James Chadwick proved that another subatomic particle, subatomic means which are smaller than an atom, exist within the nucleus called the neutrons. Now, nucleus has protons and neutrons in it. The particle had a similar mass to proton and no charge. Protons were given positive charge and neutrons are said to be neutral. Mass of the proton is same as mass of the neutron. Next, he achieved this by carrying out a similar experiment to Rutherford's alpha particle scattering experiment. There's a question time for you again. Dash, along with proton, make up the nucleus of the atom. They add to the mass of an atom but do not carry any charge. Pause, think, and answer. If you told the answer is neutrons, then you are absolutely correct. This question for you again. Arrange the following atomic model in the correct order of their development from earliest to latest. Rutherford's nuclear model, Bohr's electron shell model, Dalton's solid sphere model, Thomson's plum pudding model. Pause, think, and answer. If you told that Dalton's was the first one, then Thomson's plum pudding model, then Rutherford's nuclear model, and then Bohr's electron shell model, then you are absolutely correct. There is one more model, quantum model. We don't have to study about it, but just for your knowledge. So that was all about the lecture in the history of the atom. You can check YouTube shorts or Instagram page for more questions related to the topic. Thank you so much.